science state that nearly 14 billion years ago expansion started. Wait, the earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall.
Hi, welcome. I want to begin on 3.3 forces and motion, where we begin to talk a little bit about the effect of force. So, when we talk about force, we cannot not talk about Newton's laws of motion. I think this very famous scientist, he's come up with this law of motion, which helped to explain a lot of phenomenon. And because of this law, it has allowed us, in a way, to send men to the moon, to send satellites into orbit. So, understanding Newton's laws of motion gave us an appreciation of everything that happens around us. And so I hope at the end of this segment, we should be able to describe what happens when a force interacts with a body and its effect on the motion. Okay, using Newton's law of motion to explain it. In addition, we should also be able to describe the effect of balanced and unbalanced forces using when we talk about balanced and unbalanced forces, it brings to mind what is a balanced force and what is an unbalanced force. To give a very simplistic overview, okay, a balanced force occurs like this figurine is experiencing a balanced force. Why? Because the forces interacting with one another on this figurine is equal. The forces is balanced, and it is at a state of rest. It is not moving with acceleration in any direction. Unbalanced forces occurs when there is a larger force interacting on a body. So you have two forces. If I'm pulling over 5 Newton in one direction, 3 Newton in the other direction, the overall is there is a resultant force, and as a result, this force is considered unbalanced. This object is considered to have been experiencing unbalanced forces acting on the body. And I will conclude this segment with applying the formula of force, understanding and appreciating this. The formula force is equal to the mass times the acceleration of the body. So if we can recall a little bit, if someone asks you what is acceleration, I mean, a lot of time it causes us to pause and begin to try to understand what is acceleration. If I'm to give my simple definition or a simple explanation, acceleration occurs when the speed changes or when direction changes over a period of time. I understand that we do have this concept of acceleration as merely increasing speed. Generally, we place any type of change of speed as acceleration, although a negative acceleration would of course be deceleration. So a simple formula of acceleration would be change in velocity over the time taken. So I want to dwell a little bit on what happens, on an object when a force is acting on the object. What happens to the object? So if the object is stationary like this figure, if I am to exert a force on this object, it will begin to move. If this object is moving, then I would say there are several phenomena. It can either increase the speed quickly, or as it's moving, it will decrease the speed until it comes to a stop, or it can even change direction. Okay, so see, I'm exerting a force that's changing direction. So we understand that when we talk about effect of forces, this is something that we are able to see with our eye, the phenomenon that is happening. So my question is, when you apply a force, an object accelerates. So in the absence of acceleration, does it mean there are no forces acting on the object? Let me repeat myself. We were talking about the effect of forces. So when we apply a force, it causes the object to accelerate, which means change in speed or change in direction. But what happens when the acceleration is zero? Would it automatically mean that there are no forces because the acceleration is zero? So I just want to give you an example. Okay, right currently, okay, this figure is stationary. That means there's zero acceleration. But if we were to say there is no force acting on this object, we will be wrong, because I'm now exerting a force on the right hand side and force by my left hand. But there is zero the acceleration, simply because why? This body is undergoing a balance force phenomenon, whereby the body has balance force. Okay, the force is pulling in all direction. It has a resultant force of zero, balanced force. Okay, so it brings us back to the original concept that when there is zero acceleration, forces can still be acting on it, but they are balanced force, which means the resultant force is zero. Okay, when an object undergoes zero acceleration, it could either be stationary or it will be moving in uniform motion in a straight line, constant velocity. So let's talk a little bit about Newton's law of motion. Basically, there are three laws, and as we dive into this first law, if we try to remember simply, it is actually the law of inertia. Inertia has to do with reluctance. Okay, so Newton's first law states that for an object, every object will continue in a state of rest unless a resultant force acts on it. So as you can see from this figuring, okay, it is not going to move unless a resultant force acts on it. Or if it's in outer space and I give it a slight tug and it begins to float, it will continue in its state of rest, state of constant motion in a straight line, unless a resultant force acts on it. As a reluctant, if it's stationary, it is reluctant to move. If it's moving, it is reluctant to stop or change direction. So this is the law of inertia, Newton's first law. Okay, it is called reluctance, law of reluctance, inertia, because basically the forces that is acting on it are balanced and there is no acceleration. The forces acting on this body are balanced. There is no acceleration. It either remain at rest or it will continue in a uniform motion in a straight line. So when we look at this body, why does it remain? Are there forces acting on it? Answer is there are forces. It has a weight. Okay, but why is it not moving? Because it's countered by another force, which is the reaction from the table. There is a normal reaction force by the table on this body, and it is of equal magnitude to the weight of this object, and that is why the forces are balanced. No acceleration, the body continues in a state of rest. Okay, let's talk a little bit. We're talking about balance force. So let's bring in the scenario of unbalanced force. So when balanced force, no acceleration, it would also mean that when there is unbalanced force, their acceleration is taken into consideration. So Newton's second law states that when a resultant force acts on a body of constant mass, the object will accelerate in the direction of force. So in the same way, if I'm pushing in this direction, this figuring will go in this direction. No other way. Okay, and to calculate this resultant force, this is simply the product of the mass and the magnitude of the acceleration. Okay, so you can see, in order for the acceleration, which means that the forces acting on it are not balanced. Okay, there would be a larger force in a particular direction. So we know that when there's a resultant force, it will cause this object to accelerate. So how do I calculate the value or the magnitude of the acceleration? The second law states that the product of the mass and the value of the acceleration will give you the resultant force. F equals to ma. F is in Newton, mass is in kg, and acceleration would be in meter per second square. Okay, see, we talk about balanced and unbalanced forces. So if you were to go back, how are forces balanced? Newton's third law will begin to attempt to explain it. You know, it's like this object, the forces are balanced. So Newton's third law states that for every action there is an equal and opposite reaction. Okay, so there are 4 characteristics. Every action has an equal and opposite reaction. That means always forces that occurs in pairs. Weight, normal reaction. Weight going downward, normal reaction. Okay, and the magnitude of the forces, they are always equal. 5 Newton down, 5 Newton up for this balance force. 5 Newton, the weight, 5 Newton, normal reaction. And they always act in opposite direction. And they act on different body. Weight exerted on the table, normal reaction exerted on the figuring itself. So this is third law. Third law is a very interesting law. Okay, it explains a lot on how we sent even satellite into outer space. And with that, we wrap up on 3.
The universe was in a hot, dense state that nearly 14 billion years ago expansion started. Wait, the earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall. We built the pyramids, math, science, history, unraveling the mystery.